I am going to talk today about a summary I wrote that I was commissioned to write for the Southwest Fire Science Consortium and the Ecological Restoration Institute at Northern Arizona University. So none of this research is my own. I just compiled what's known about climate change and fire in the Southwest into one short, readable document. And it's a place for people to find citations or information about things they're more interested in. So what I'm going to talk about today just really covers that working paper. And what I'm going to go over is, first of all, I want to talk about why it's so hard to predict any of these things, climate itself in the future, and also climate change effects on fire and other things. So the different levels of uncertainty that people are dealing with when they're trying to predict climate change and its effects. So I'll start with that, and then I'll move into what is predicted for climate change in the Southwest in terms of temperature, precipitation, and extreme events. And then I'll get into the bulk of the talk, which is how it's going to affect fire through changes in fuel moisture, changes in fuel loading, and changes in ignition, which have been proposed as the 3 ways that climate change is going to affect fire in the Southwest. Okay, so getting into why it's so hard to predict this stuff, there are several levels of uncertainty when you're thinking about climate change in the future. The first thing that we don't know for sure is how many emissions are going to be coming out. It depends on global population, how many humans are going to be here in the world. Also economic development, what countries are going to be increasing their car purchases, all sorts of technology. Also energy and technology development, whether we develop cleaner technologies or not. And then finally, agriculture and land use emissions. And some of the things that are not, hard to predict are deforestation, but also things like rice cultivation and fertilizer application. Those things also influence emissions. So all hard to predict. So that's the first step. Then from emissions, you actually try to predict atmospheric concentrations of greenhouse gases. And that depends a lot on emissions, but it's not a one-to-one correlation. It's not 100% of emissions go into atmospheric concentrations because there is an exchange between the atmosphere, ocean, and land. So, forests can take up greenhouse gases, so can the ocean. So that's another level of uncertainty. The next level of uncertainty is what's called radiative forcing, and that's energy that warms the earth. And that depends on greenhouse gases, but also several other things that all have to be predicted and assumptions have to be made, including ozone, water vapor way high in the stratosphere, surface albedo, which is reflection, how much white is available, white surface cover is on the earth versus dark colors, a cloud albedo effect, which is similar, and then actually how much solar radiance is coming in. So this radiative forcing term is just what's called the difference. It's basically defined as the difference between what solar energy is coming in and then the energy that radiates off the earth. So that's another level of uncertainty in predicting climate change. So the next thing to try to predict is climate change itself. Things like temperature, of course, and then precipitation, cloud cover, storm tracks, any other changes in climate that could happen in the future due to all these other things in this chain of events. And then finally, what we're really interested in is impacts of climate change. So that's on fire, which is what I'm talking about today, but also human health, air quality, biodiversity, all sorts of things that people are interested in. So this chain of uncertainty, these different levels of uncertainty kind of make it more obvious why it's so hard to know for sure what's going to happen in the future. But I guess I just wanted to point it out because, when people come up with different answers, it's just because it's so complicated. Okay, so given all that, I'm going to move into what climate change predictions are for the Southwest. And so for temperature, that's the thing that people are most sure about. And it's predicted that temperature will increase by at least 3 degrees up to 9 degrees by the year 2100. It's predicted that bigger temperature increases will be seen in the summer and the fall. And we'll have 17 more freeze-free days by 2100. Again, that's an estimate. There's no disagreement among models that temperature will rise. The only uncertainty in the case of temperature is how much it's going to rise. This is a figure looking at the Southwest. So here on the left-hand column where I'm highlighting, that's a high emissions scenario, and on the right over here is a low emissions scenario. And then each map represents a different time period. So over here on the top row we have the years 2021 through 2050, next 2041 through 2070, and then the last time period is 2070 through 2099. And so you can see that the temperature, how much we're going to see an increase, depends on which scenario we're going to use and then how far out in time you're looking. And this farthest out, by the end of the century with the high emission scenario, is where those predictions of up to 9 degrees Fahrenheit increase come from. Okay, so for precipitation, predicting precipitation in the Southwest and everywhere really is difficult, especially in the Southwest because variability is very high. Even now, variability from day to day, week to week, season and annually is much higher in the Southwest than some other parts of the United States and some other parts of the world. So it's difficult. We all know precipitation is hard to predict even tomorrow, and it's another step down the uncertainty chain from, if you think about it that way, from temperature, because temperature is more closely related to greenhouse gases, whereas precipitation depends on a lot more, movement of the atmosphere and jet stream and things like that. So people have come up with different predictions for precipitation depending on which emission scenarios they use, what kinds of models they use, and what approaches they take. So I'll talk about what we don't really know about precipitation. One of the things that doesn't seem to be sure is how much total precipitation will change on an annual basis. I saw one study that predicted higher total precipitation in the Southwest. Several other groups have predicted lower precipitation totally, on a total annual basis. It's also not certain whether the whole Southwest will be affected in the same way. It's possible that more precipitation will be seen in the northern part of the Southwest and less in the south. So it could be a regional difference even within the Southwest. Summer precipitation is also unclear. The monsoon is poorly understood and modeled right now, and so it's really difficult to know what will happen with the monsoon in the future. And then winter precipitation as well. It's been predicted that we'll have decreased winter precipitation because storm tracks will move north, but other people have predicted increased winter precipitation. The one thing that does seem to be agreed upon is that winter snowpack is likely to decrease because of increasing temperatures, which is a sure thing. And what decreased winter snowpack means is likely reduced spring runoff and decreased soil moisture by early summer. So this is something that could affect fire conditions here in the Southwest. Okay, in terms of extreme events, it's been predicted that heat waves will increase in frequency, so how often they occur, intensity, how extreme they are, duration, how long they last, and then spatial extent, how big they are. And with that same prediction came a prediction that higher relative humidity during heat waves will keep nighttime temperatures particularly elevated. And this is something that might affect human health more than fire. For example, in big cities like Phoenix or Las Vegas, to have heat waves with high nighttime temperatures as well. Both enhanced precipitation events and droughts are projected to intensify. And droughts have been predicted to be worse than any drought for almost 1,000 years. In the medieval climate anomalies, when the last time we had droughts as bad as the ones that are predicted. And they might last longer than historical droughts. One prediction was up to 12 years of extreme drought. Okay, so that's all I have for predictions of climate change in the Southwest, and I'm going to move into impacts of climate change on fire. So despite those uncertainties in how precipitation is going to react to climate change, a lot of people have tried to predict what's going to happen with fire. And Amy Hessel, a few years ago, wrote that there are 3 pathways that climate change could impact fire. And this is globally, not just here in the Southwest. And those 3 pathways are through fuel moisture, fuel loading, and ignitions. And that makes sense if you think about the, I kind of made a link here between those 3 pathways and this fire environment triangle or fire behavior triangle. And topography is, so the 3 things that affect fire behavior, fire currents are fuel, weather, and topography. And so topography is not going to change with climate change for the most part. But these two things could. And so weather is sort of related to that fuel moisture component of her pathways of how climate change will impact fire. The fuel loading is really that fuel leg of the triangle, and then we'll add ignitions onto that fire environment or fire behavior triangle. I think that makes sense to me, and hopefully that will help someone here remember these kind of three pathways for how climate change could impact fire. Before I dive into those three pathways and give you some examples of research that have been done, I want to have some things to keep in mind here before I start. The first thing is that different ecosystems will respond differently to climate change and these three pathways. So fuel moisture is most likely to affect ecosystems where fires are typically limited by fuel moisture. Those would include higher elevation, higher latitude, and wetter ecosystems for the most part. And I have a picture over here as an example of the Paradise Fire, which is burning in Olympic National Park in Washington State. And that's a place where most years the fuel moisture is not low enough for a fire to be able to carry. This year it's very hot and very dry, so that change in fuel moisture is allowing the fire to burn in that ecosystem. Fuel loading, that pathway for how climate change will affect fire, that's most likely to affect ecosystems where fires are typically limited by fuel, and those could include drier and less productive ecosystems. Ignitions, that's the least understood pathway for how climate change might affect fire. Changes could probably happen anywhere, but it's been pointed out that ignitions are rarely the limiting factor for fire these days, so it may be also the least important pathway. Okay, the other thing to keep in mind, another thing, is that there are multiple fire regime attributes that people might want to know about in terms of predictions for the future, including the type of fire, surface or crown fire, intensity, fire intensity, which is heat of the fire, severity, which is ecological effects, area burned, patchiness, and seasonality, and then frequency. So I've tried to incorporate some questions for you throughout this presentation to keep things more interesting. So let me just add a poll here on the left, and then go ahead and answer the question and this is just, there's no right or wrong, in terms of what you think, what would be the most important to try to predict, what would you be most interested in? Fire intensity, fire severity, area burned, or frequency, which is kind of like fire occurrence. Xander, how do I see the answers?
Well, I'm not quite sure, but I'll just tell you that 67%, 6 people say that severity is the most important to predict, with one person saying area burn and one person saying, or 2 people saying frequency.
Okay. Well, I was interested in that because I think severity, a lot of people would be interested in that. I was thinking that would be interesting to know. And it turns out that what's most often forecasted is area burned, and that's probably the most easy to tie to different factors with climate. Frequency or fire occurrence is also sometimes forecasted, but fire severity is very difficult to predict, so it's been done very infrequently. Okay, I'll do more quizzes throughout this time, so Xander, you'll just have to tell me what the answers are.
Yeah, I think when you look at that same little set of that little menu, there may be an option to share or something.
Oh,
I
okay.
can also read them out, no problem.
Okay. All right, so moving on. Another thing to keep in mind is that short-term and long-term climate change impacts on fire might be different. So for example, in the short term, we may see increased fire risk if we have higher temperatures, longer fire seasons, and lower fuel moisture. Over on the right is the U.S. drought monitor for the western United States from a couple of weeks ago. So if we see conditions like that frequently in the near future, those are conditions for high fire risk. However, in the long term, we may see fire risk decrease if fuels change. So if a forest doesn't return after a fire, or if productivity declines. So just something to keep in mind, that short-term, long-term might be different. It could change over time. And then the last thing to keep in mind is that we've had a lot of land use changes in the Southwest, including fire exclusion, logging, and grazing, which I'm sure everyone as well aware of. But those altered forest structures and increased fuel loadings could magnify the impacts of climate change. For example, when both high fuel loads and climate conditions allow for the occurrence of a severe crown fire. Okay, so now I'm going to move into, I'm going to basically go through examples of research projects that have been done on different pathways of climate change impacts on fire. So I'm going to start with fuel moisture, and there's a few different things I'm going to talk about here. How climate change could impact fuel moisture, which is through changes in fire season, changing climate patterns, and changing fire weather. So again, none of this is my research. I'm basically going to show you examples of recent research that people have done in order to come up with these predictions. Okay, so the first study I want to talk about, maybe a lot of people have seen. It's from 2006, so it's been out there almost 10 years. And this is by Tony Westerling and other people, talking about, and it's showing, they found that a lengthening fire season was evident across the western United States, and it was linked to more large fires and fires of longer duration. So this graph right here shows the bottom of this red line, down at the bottom where I'm highlighting, is the date of first discovery. The top of the red line, which I'm highlighting now, is the date of last discovery in a year. And over here on the y-axis, we have the date of the year. And so this is basically just showing how long the fire season is, the difference between this bottom of the red line and the top of the red line. Then the top of the black line is showing the date of last control. And so what they calculated is that the average season length, which is the time between the bottom of this red line, first discovery, and the time of last control, the top of the black line, increased by 78 days between the start of their analysis and the end of their analysis. And that 78 days longer, comparing about 1970 to 1986 with the second half of this graph, which was 1987 to 2003. So a much longer fire season is something that they've already found between 1970 and 2003. And that was for the western United States. That's where this study was done. Another study that just came out this summer, 2015, is showing a similar result but across the globe. And this is a map of the world, obviously, and it's showing significant trends in fire weather season length from 1979 to 2013. So anywhere that's yellow is not shown, they did not find a change in fire weather season length. Anywhere that's red, which includes a lot of the western United States here, is showing a significantly longer fire weather season length between 1979 to 2013. And over here on the right, you can see the scale here. And so this reddish, between 1 to 2 days per year change is what we're seeing here in the western United States. And you can see a lot of the rest of the world as well as seeing longer fire weather season length. So we've got results from the western U.S. and globally with increased fire weather season length. Okay, in terms of predictions for the future, it's similar. That people are saying we're going to see longer fire seasons in the future as well. This is a study from 2013, and this group found that fire season is projected to increase around the globe in places where the fire season isn't already all year. So anywhere where there's dots, all these dots mean that the fire season is already pretty much year-round. Anywhere with the orange color is that means that the fire season will increase. They predicted 3 to 20 days, and anywhere with the red color, they're saying that the fire season will increase over 20 days. And this is a prediction for the years 2041 through 2050, and it's comparing that to the 1971 to 2000 base period. So some parts of the Southwest, it looks like, we'll see between 3 and 20 days longer fire season, and then some places we'll see a greater than 20-day increase in the fire season. Okay, and then this is my last slide on changing fire season, and this one I know there's a lot going on, so I'll walk you through it. This group, 2014, found that the changing fire season is true not only for small fires, but also for very large wildfires, and they categorize those as over 50,000 acres, and that fire season is also projected to lengthen. So these 8 maps right here were found to be good predictors for large fires, those 50,000 acre plus fires. So here on the top left we have burning index. The next one is DUF moisture code. The next one over here on the top right is fine fuel moisture code. Then we have energy release component. And then right in the middle is 100-hour fuels. Middle right is 1,000-hour fuels. The bottom left is PDSI, which is Palmer Drought Severity Index, an index of how much drought there is. And then the bottom right is temperature. And the colors of those different maps, for the top 6 maps, this scale right here, the top scale is what you're looking at. So anything that's redder means that there'll be a more significant increase in the period 2031 to 2060 compared to the more recent past. So some of those things it looks like the Southwest will be more impacted by. So the top right, if you look at this one, fine fuel moisture code, they're predicting that darker red areas, or we'll see a more conducive conditions for those very large 50,000 acre plus fires. Another thing to look at is PDSI, which is the bottom left. That's another one where we're going to see pretty drastic changes. The darker colors mean that we'll see increasing drought in terms, as measured by the Palmer Drought Severity Index. And then the bottom right is temperature, and again, darker colors mean bigger increase in temperature. And again, all these different 8 different maps are showing predictor variables for those very large 50,000 acre plus fires, and those are all predicted to become, a little bit worse to much worse over the next couple of decades. Okay, so what I've shown you is a couple of studies showing that fire season length has already increased in the U.S., and then 2 studies showing that, or predicting that fire season length will increase in the future. So I'm not using these answers for any thing other than just interest right now and maybe a starting point for discussion at the end of the talk, but I would just want to hear from anyone whether true or false you've noticed a lengthening fire season. Okay, and I can see the results now. So 88% of you, 89% have noticed a lengthening fire season. Okay, so we'll just do that throughout the talk. I'll see what you've noticed. Okay, the next topic to get into is just changing climate patterns. And I'm going to start with just temperature relationships and a prediction for how temperature will change fire occurrence in the western United States. And this study was from 2009, showing that increasing temperature will lead to 54% more area burned across the American West in the period 2046 to 2055 compared to a base period of 1996 to 2005. And this map down here is showing that, the different colors are sort of how much higher the area burned will be in different areas than that base period. So the Northern Rockies are what they predicted will see the most increase in area burned. The Southwest, for the most part, will see a modest increase in area burned, and then the Northwest is somewhere in between those 2 regions. Okay, this study is showing similar thing. This map over here is just showing study area. So here's Wyoming, Colorado, and New Mexico. So their study area was inside this blob here, the Southern Rockies. And what they showed is that the area burned and number of fires have been increasing already. And so now look down here at this graph on the top. So here's 1970, here's 2010, and they showed that there's already been an increase in area burned over that time period. There's sort of an upper trend there. And then they continued that analysis and predicted that area burned will continue to increase through the year 2070, that was the length of their study, by 2 to 5 times due to temperature and precipitation changes. So now look at that bottom graph. Here's 2010 on the left, 2070 on the right, and again we're looking at area burned, and they used several different models, and again they predicted the increase in area burned over that time period. Okay, so that's all I have for area burned. True or false, whether you have noticed increase in area burned? Okay, so that one is a little bit less. We've got 60% to 40% on area burned. 60% have noticed an increase in the area burned. Okay, again, something to maybe talk about in the question and answer discussion period. Okay, another way the last way that climate change could impact fuel moisture is through changing fire weather. And I didn't find any research on wind. That's something that's another really hard to predict. But I did find this study on relative humidity. And this was a study from 2004 predicting that decreases in relative humidity through the year 2089 will lead to more days of high fire danger in the Southwest, as measured by the ERC, which is the energy release component. And most of you probably know the energy release component is related to how much total available energy per unit area is available to burn. So it's kind of a worst case scenario, how hot a fire could be, and it depends on both the fuel model and fuel moistures. And that map at the bottom is just showing the ERC from yesterday. So again, this study found that there might be more, they determined that there will be more days of high fire danger in the next several decades. Okay, so again, true or false, I have noticed an increasing number of days of high fire danger. Okay, again, we have majority of people saying that they have seen an increase in number of days of high fire danger. We're at 83% yes on that one. All right, the next topic I'm going to move into is how climate change might impact fuel loading. And these things are all related, how fuel moisture, fuel loading, they're kind of related, but I'm going to focus on a different set of pathways here. So the ways that climate change could impact fuel loading is through changes in dominant species, insect outbreaks, mortality events, severe drought, severe fire, reduced fire, or changes in regeneration. And so I'll go through some examples of research that have been done on some of these different things. So this is a study that came out in 2009 showing that tree mortality events are already increasing in the western United States. The red dots are locations where mortality increased during the time period of the study. The bigger the dot is, the higher the level of increase in mortality. So that's for the western U.S. And there was also a study in 2010 that came out showing that mortality events were prevalent around the world as well. So on this map, all the white dots you see are locations where it was documented that there was documented forest mortality due to climatic stress. So we've already got places where vegetation is dying off, which could be a pathway for how climate change will impact fire. Okay, in terms of vegetation shifts, there was a study in the Southwest showing that from 2012 that predicted that vegetation cover will decline overall. Most species were predicted to shift north by an average of 58 miles. Yucca and oak were projected to expand their ranges, whereas pine and juniper ranges were projected to shrink. This is the only study that I included in this talk in terms of species range shifts, but there are other studies out there. And this again it depends a lot. The answers depend a lot on the approach that people take and how they are doing these studies. But this is one example of some results that people got for what's going to happen with vegetation, both cover and then species ranges. So again, this changes in dominant species cover would is an obvious way for how climate change could impact fire. I really like this study. I have used it many times in different talks because I think it's a really good example of how climate change can affect ecosystem really quickly. This was a study from back in 1998, and they had a study area in northern New Mexico that they looked at several decades later through tree rings. They looked at tree ring evidence for what happened during the 1950s drought. And they found that the ecotone, which is the boundary between ponderosa pine and pinyon juniper woodland, shifted. It shifted over 1.2 miles in less than 5 years. And so looking over here at the map of their study area, the green area is where ponderosa pine forest is located. The yellow is pinyon juniper woodland. And all the red area in the between is where that ecotone shifted. So it was ponderosa pine and it became pinyon juniper in that very, less than 5 year period. And it just shows how range expansions and contractions can happen very quickly. So, climate change may not happen over decades to decades. It may happen in just a very quick extreme event. So there's an example for changes in dominant species, which again, just bringing back to the title of the talk, is how climate change could impact fire. And then related to that, this is looking at a study from 2010 showing all of the area in the Southwest that have been impacted by either bark beetles or fire in the last couple of decades. So this study found that around 10% of forests and woodlands were heavily impacted by bark beetle-induced mortality between 1997 and 2008. And those places are shown in orange on the map. That's the orange color is bark beetle. They also found that around 3% of forests and woodlands were burned in moderate to high severity fire from 1984 to 2006. And those fire-affected places are shown in red on the map. They also concluded that both the bark beetle and the fire impacts on forests and woodlands were related to drought and high temperatures. Okay, and then finally, thinking about regeneration in the Southwest, that's another way that climate change could impact vegetation and therefore fire. Regeneration after severe fire, especially in ponderosa pine, but other places, can be really variable. It can result in dense stands of young trees, or tree regeneration may not happen at all. And there was a study that came out last year in 2014 that showed that it was a modeling study that concluded that even without severe fire, changes in regeneration patterns could result in forests converting to non-forested ecosystem over the next century if the most severe emission scenario occurs. So regeneration shifting to non-forested species or different forest species could also change the landscape, which would then change fire. Okay, so we have another true-false here. This is a long true-false question, but let me know if you have noticed changes in fuel loading due to any of the following: changes in dominant species, insect outbreaks, mortality events, severe drought, severe fire, reduced fire, or changes in regeneration. Okay, well, I'm not sure how many people are responding, but right now it says 100% true.
There are 8 people who have responded so far.
Okay, great. Okay, I guess these, all of these things may not be directly tied to climate change, but they're all ways that climate change could, work in a pathway towards changing fuel loading and then therefore fire. Okay, so to kind of conclude on fuel loading, so changes in fuel loading, we could see increased fire activity if fuel loading is enhanced. We might see decreased fire activity if fuel loading is diminished. But I also wanted to just, point out that even if fire activity increases, there's got to be a self-limiting aspect of fire over time, with severe fires only able to burn when enough vegetation has grown back to carry another fire. So it's unlikely that we can continue to see increased area burn and severe fire, over a long time period. There has to be a self-limiting aspect to it eventually. The last thing to point out with this topic is that a lot of times people use past climate fire relationships in in kind of thinking about the future. So for example, relationships between climatic oscillations and when fires burn. But Amy Hessel in that same paper from 2011 pointed out that past fire-climate relationships may not hold true for the future, and for a few different reasons. The first one is that climate-fire relationships are specific to particular ecosystems and fuel types, and vegetation shifts and fuel changes might occur. And these two maps at the top are just showing current range of ponderosa pine and a potential map of ponderosa pine in the future, depending, with a given model and emission scenario. So, where we know a lot about ponderosa pine in the Southwest, but if it's not there in the future, that we're going to have maybe potentially different fire-climate relationships. Another reason that those fire-climate relationships may break down or change is because climate change might be favorable for invasive grasses. And if it also increases fire ignition and spread through higher temperatures and lower precipitation, we could see increase in that fire invasive cycle. So that's another reason why those fire-climate relationships might not hold true in the future. And then finally, although they're not tied directly to climate, humans may change their ignition or suppression patterns. We have a lot to do with what burns when as well. This map I just think is kind of a cool map showing the human footprint in the American West. It has nothing to do with fire, but it just shows places that are heavily impacted by humans versus places that are pretty untouched by humans. And so depending on us as well, we could change those fire-climate relationships depending on what we do over the next century. All right, so the last pathway for climate change to impact fire is through ignitions. To my knowledge, there's only been one study predicting changes in lightning with climate change in the Southwest, and that was all the way back in 1994. They predicted that the number of lightning fires will increase by 61% and that the area burned will increase 141%. And that was in a scenario where CO2 doubles. And they said that that increase in number of fires and area burned will be due to an increase in thunderstorms and a decrease in precipitation. Ignitions are definitely the least understood pathway for climate change to influence fire. Okay, so true or false? I've noticed an increase in lightning-started fires. Xander, how many people have responded?
We've got 5 people who say they have not seen, 6 people who say they have not seen an increase in lightning-started fires.
Okay. All right, so we'll move on. So I'm getting close to the end here. I'm just going to go through a summary of climate, just straight climate, and then I'm going to go through a summary of climate change impacts on fire, and then I have one slide for things to think about for management. So to summarize the climate predictions, climate change will increasingly alter climate averages, extreme climate events, and ecological processes in the Southwest. Temperature is universally forecasted to rise. On the right here, the map of the world is showing the temperatures this year, January through July 2015, compared to the average temperatures between 1981 and 2010. So we are on track for another record year globally in terms of temperature. And those are just increasingly going to rise on average over the next century. Precipitation in the Southwest could go up or down, and there may be variability as well by region within the Southwest and by season. It's much more agreed that snowpack and spring and early summer runoff will be less. And there have been several people predicting that droughts will likely be more intense and last longer. Okay, so that's a summary of climate. A summary for climate and fire. There are 3 pathways that climate change could impact fire. The first is through fuel moisture, which could happen through longer fire seasons, increased temperatures, decreased relative humidity, and changes in precipitation. The second pathway is through changing fuel loading, which could happen through tree mortality and loss of vegetation cover, species range shifts, changes in regeneration, and then disturbances themselves, like insect outbreaks and severe fire. And then the last pathway is through changing ignitions, which we don't know as much about, but may not be as important. And then just to summarize a couple of my take-home points too is that ecosystems are going to respond differently. So places where fires are generally limited by fuel moisture are going to be most affected by changes to fuel moisture. And those are those wetter, more productive ecosystems that typically need a drought year to burn. And then where fires tend to be limited by fuel availability, those will be obviously most affected by changes to fuel loading. And those will probably be those drier, less productive ecosystems where fires currently might be limited by fuel continuity. And then the impacts of climate change on fire might change over time. So it's probably not going to be a constant increase or decrease. It may be high initially, but decrease in the long term if we see changes in vegetation or fuels. So for management, and we can discuss this too if we have time at the end. The one thing that we know is that change in southwestern ecosystems is inevitable. And so for me, I think it just makes sense to always have it in the back of your mind, even if you don't know exactly what to do about it. Just knowing that it's going to happen, I think is a good start. And it's got to be considered in managing despite all the uncertainties that I talked about. Some of the other challenges, of course, is that other things are changing at the same time, including land use, population density, invasive species, and fire management itself. One thing that's been proposed as a way to respond to climate change is thinning and burning treatments, which are already happening. They have been shown to reduce fire severity, and so that is a way that maybe people could buy time for a forest and maybe increase the resilience to climate change. If you prevent a severe fire, well, at least you still have a forest, which may be able to respond to climate change in some way. And another option for managing is to just think about what is most important on a landscape and maybe manage for not particular species, but for clean air, clean water, soil health, or just native species in general instead of picking one species. So those are a couple of the ways that people have proposed for responding to climate change. And then I put a link here at the bottom for where the Forest Service has put together an adaptation plan from last year. I want to just point out where to find this working paper with all the references that I cited, in addition to some more that I didn't get into today. And there's a link here at the bottom where you can find it. And then I also just wanted to pause on these references for a couple of seconds each. I think this webinar will be available online, so you could just go to the end and look at these references if you're interested in one of the studies in particular. And with that, that's all I have for today. So thanks for being here. And if anyone has comments or discussion points or questions, let me know.
Yeah, that's great, Larissa. You did a really nice job in walking us through quickly but clearly a lot of information. I'm going to go ahead and unmute the line. So if if you're snacking up potato chips or something, mute your phone on your end. And we can have a little bit of conversation. And maybe we'll start, Don Falk typed in a question, and he was making a connection to Mexico and asking what we know about similar developments in Mexico and whether there's any data there that kind of crosses over.
That's a good question. I would think that most of these predictions would be very similar for Mexico. For this working paper, I didn't include anything that was outside of either the Southwest specifically, or I did use some global analyses too. But I think there's been a lot less work focusing only on Mexico, but I'd have to say that it's got to be very similar because the ecosystems are similar, and so is the climate in a lot of places.
Great, and I'll go ahead and unmute the line here. I guess one of the things that really struck me, and it's nice having a concise presentation of all this material because it's easier to get in the head, and this issue of as vegetation changes, basically as forests burn, there may be less available to burn, and maybe that seems somewhat counterbalanced by this sort of vegetation change issue. And it's also, it seems, at least lately in the Southwest, we've seen some of the reburn. So I wonder, I don't have maybe a very clear question in mind, but I'm wondering whether, just in your review, Larissa, whether you felt that the sort of countervailing forces of large fires burning through material so there's less available, and then at the same time maybe a regrowth or dead material on the ground being available for high severity fire reburns. What do you feel like is how might that wash out?
Well, I think that's a really good question. I mean, I think, it was interesting to see how a lot of the studies that I looked at were predicting increased area burned in the future, and some of them had really drastic area burn predictions. Up 600-something% in some parts of the United States, Western United States, and you think about that over the long term, and those were most often based on weather conditions. So increased temperatures, less precipitation. So the relationship between those climate variables and area burn, we know that in current times. So if we're going to see hotter, drier conditions, we'll see more area burn in the future. But I think that can't continue forever. So I think it's going to be really interesting to see, for example, on the Mogollon Rim, we've had already, the Rodeo Chetasky Fire and the Wallow Fire. Those each burned close to or over 500,000 acres. And there really isn't, I don't know the numbers, but we couldn't have that many more of those types of fires on the Mogollon Rim without burning everything at least once in giant fire. So I think it's unsustainable to think that area burn could increase forever. So one of the things I think is really becoming a bigger focus is what's going to happen to those severely burned areas, especially in terms of regeneration, what's going to come back, and then also whether areas could reburn severely again. I think that's the focus for more research that's coming up, but I don't know. I mean, probably people on the line would maybe have a better answer to that than I do. I think it's really hard to kind of think about that balance of how area burn is going to increase, but at the same time have fuel available for the next fire after that.
Fair enough, fair enough. Other questions or comments, feel free to type them in or say them out on the phone line. Well, maybe we've depressed everyone's or your presentation was clear enough that there are not a lot of questions, and well, maybe we'll just wrap up. We're just about at the top of the hour. We will have a recording of this webinar available, so since it is a nice, clear, concise presentation of the material, if you want to share it with other folks, you'll get a link in an email soon as follow-up, and you can send that out. And, of course, there is the working paper itself for follow-up. Larissa, thank you again. I think you did a really nice job, and it's a pleasure to have you on the webinar series.
Thank you.
Great. And with that, I'll close off the line and hope to have some of you back for future webinars.